Guess what this video is about? It's about matter. We want to think about what matter is. You've heard about matter in other science classes that you've taken before you've gotten here to chemistry class. And now we want to really kind of boil it down to some words. What are we really thinking about when we're thinking about matter? There are lots of different ways in which we can write down a definition of matter. Here's one of them that we might find in a lot of different textbooks. Matter is anything that has mass and takes up space. Some books might write it a little differently than that. There's another way that we can define matter. Matter is anything that has mass and volume. And the red sentence and the blue sentence here are really pretty much the same because volume is the amount of space that something takes up. So these are two different ways of defining matter, two different ways of saying pretty much the same thing. There's another way that we might define matter. We might say that matter is anything that's made of atoms. And that's a definition that will work pretty well for us in our chemistry class. You might get an argument that there are some things that are not atoms or that are parts of atoms that are also matter. But for us, if we come across something that's made of atoms, that something will be matter. There's another definition here, the black one here. Matter is stuff. Doesn't sound very technical, does it? But it is a pretty good way to define matter. Your stuff is matter. My stuff is matter. So we could think of it this way. If we had some stuff, that stuff would be matter. Let's look at a few examples here. Here are 4 definitions. Here's a picture of some rocks. So are those rocks matter? Well, if we took some or all of those rocks and put them on a balance, we'd register a mass. So they certainly have some mass. We wouldn't even have to put them on a balance, would we? We could just pick them up and tell that they had some mass to them. And they certainly take up some space. So yeah, those rocks are matter. It's pretty easy to see that those things are matter. Here's a car, nice little metallic blue car. Don't know what kind of car that is, but that car, obviously, matter, takes up space. It certainly has some mass. If we had a balance or a scale that was big enough, we could weigh that car. The manufacturer probably does know how much it weighs. So that's definitely matter. Does it take up space? Yeah. A car takes up space, and we know what the consequences are when 2 cars try to occupy the same space. They can't do it because each car needs to have its own space. So yeah, the car is an example of matter. Here's some balloons. So if we had these balloons in the package before they were filled with whatever they're filled with, we could take a balloon that wasn't tied up, we could put it on a balance, and we could see that it has some mass. And we could also know that the package, if we have a package with a bunch of balloons in it, the package is kind of filled up. So the balloon by itself, the latex or the plastic that the balloon is made out of, is matter. What about the gas that's inside the balloon? So if these balloons were blown up by a person, they would be filled with air, air from that person's lungs. Is air matter? Well, the air certainly takes up some space. The balloon, when it's filled with air, occupies more volume than the balloon when it's not filled with air. So the air inside the balloon must be taking up some space. Does the air have any mass? Well, that's a little harder to see, but if we had a sensitive enough balance, we could weigh the empty balloon, and then we could weigh the balloon with some gas in it, and we could see that the air inside that balloon did have some mass. So yes, the air is matter. What about if the balloon was filled with helium now? So the helium would certainly occupy some space, but the helium inside the balloon doesn't seem to be attracted to the Earth. If we let go of a helium balloon, a balloon filled with helium, it looks like these balloons might be filled with helium because they seem to be being tied down at the bottom or below the picture. and they're pulling up in the air. If we let those balloons go, and the helium balloons went up in the air, does that mean that the helium doesn't have any mass? Well, it does not mean that. If we were able to follow those balloons up in the air, we'd get to a point in the atmosphere where the helium was no longer less dense than the air, and the balloon would stop going up, and the balloon would stop going up because it's still, the helium inside it is still being attracted to the gravity of the Earth. So the helium does have some mass, even though it's a little bit more difficult to see or for us to observe in just a casual way that helium has some mass. So air and helium, both types of matter. What's this? CuSO4, capital C, lowercase u, capital S, capital O. Well, this is a chemical formula. And we're going to learn as we go along in chemistry that these symbols that are here, the capital C and the U together, capital S and the capital O, are all symbols for different kinds of elements. And when we write a formula like this one, each symbol represents an atom. So this formula, the way it's written right here, is telling us that we have a compound that consists of one atom of copper, one atom of sulfur, and 4 atoms of oxygen. Cu stands for copper, S for sulfur, O for oxygen. So this formula is telling us something about atoms that are combined to make a compound. Let's look at our green definition here. Matter is made of atoms. So this stuff that is made of atoms, even if we don't know what it is, we can look at this formula, we can understand that these formulas are symbols for chemical elements, and they tell us about the number of atoms in a single unit, a single small unit of this compound. So that is a signal to us that this formula represents some type of matter. We're going to see lots and lots of chemical formulas in chemistry class this year. What about liquid? Here we've got 2 glasses in this picture. There's 2 separate pictures here. Here's an empty glass, this tall drinking glass here that's sitting on a table. And this picture here of a shorter glass, but it's filled with water. And you can see that water has a few bubbles in it at the top. So this glass is nearly filled, or probably about 2/3 filled with water. And this glass is empty. So, is the water matter? Well, yeah, it is. It takes up some space. It fills up as much of the glass as we poured water in. So, this glass is about 2/3 filled with water. Is this glass heavier when it has water in it than when it doesn't? Yes, of course it is. So matter, or water that is matter because it has mass and it also has volume. So we've talked about liquids, we've talked about some solids, the car, the rocks, the CuSO4, that's a solid under most conditions. We've talked about the balloons, the plastic part of the balloon, all those solids are matter. We talked about the gases inside the balloon, the air and or the helium that are in those balloons. That's also matter. We talked about water in its liquid state. That's also matter. And that leads us to another definition, or something we could use as a definition of matter. Anything that's a solid, a liquid, or a gas is matter. All matter is solids, liquids, or gases. Some people would add plasma to that list. We're not going to worry too much about plasmas. It is a kind of a state of matter. But things that are liquids, gases, or solids are matter. So we've got lots of different ways to think about matter, lots of different ways to identify whether something we're looking at or reading about is matter. And that's going to be important to us. Why? Because of this slide, which I gave you a preview of a minute ago. Chemistry is the study of matter. And not only is it the study of matter, but it's the study of matter and its changes. So we're not just looking at the rocks to see what they look like, but we might look at them over a long period of time, or we might imagine that they've changed, or we might be able to make them change by doing something to them. And similarly with the other things we've talked about, and many other types of matter. We can see them change, we can predict when they will change, we can study what they change into. So chemistry is the study of matter and its changes, which is why we're interested in matter. So here's something that we're going to think about from time to time. This is a way of thinking about what chemistry is, or why we're interested in studying chemistry. So chemistry is kind of a way of representing things that we can observe or measure in the laboratory or the real world, things that we can sort of get our hands on or get our eyes around. We can connect those things to what scientists understand or have come to understand about what's happening to the tiny little particles like atoms and molecules and electrons that matter is made of. So there we go. What we can observe, we can describe in terms of what's happening in those to those little particles. And then the other thing that we're going to be concerned about in chemistry is how do we use symbols like the symbols we saw when we looked at the formula CuSO4 and the or formulas or certain kinds of numbers to represent the things that we can observe or the things that are going on the very, very small submicroscopic level. So in chemistry class, we're going to try to make a relationship among all three of those things. So that's a look at what matter is. We'll be hearing more about it as we go along.